right? So we got to find this normal line and tangent line, and if you don't know, a normal line is just a line that's perpendicular to the tangent line. So we got three steps we have to do. We have to find the slope of the curve at the indicated point, x equals 1 of this function here, and then we're going to find an equation of the tangent line and find the equation of the normal line. When I start this, probably the best thing to do is to plot x equals 1 here. This is the x-axis, and there's x equals 1. Well, let's figure out what the y value of that point is by evaluating this function. So I'm going to do just right here, f of 1 would equal 4 minus 1 squared, or 4 minus 1, which is 3. So f of 1 equals 3, or the y value is 3. So I know that my point here hits about right there, and this coordinate is 1, 3. Okay? So, what I want is to find the equation of some tangent line that runs right through here. I'll draw it really light. Sketch that on there. Something like that right there. I'm finding the equation of that line and the slope of that line. So number 1 says, what's the slope of that line? Number 2 says, find the equation of that green line. And we'll see if it kind of matches up when we're all done. Okay. So now let's go over here to our instantaneous rate of change equation. And we're going to plug in our x value in for a. And so it's going to look like something like this. It's going to be f. It's going to be f of 1 plus h minus f of 1 all over h, where we're evaluating these two f of 1 plus h in for this function here. Okay, so this is going to turn into the following. I recommend making a pretty massive numerator here. So we're going to plug in 1 plus h in for this function. So it's going to be 4 minus 1 plus h squared. That's 4 minus x squared, and I'm plugging in 1 plus h. And then I'm going to turn around and plug in f of 1 into that, which we already did. We know that that's 3, so I think it's okay to just say that equals 3. So we're going to take away 3 there. Over h, and remember that's going to stay h. And now we have to simplify. So I guess that wasn't as bad as I thought. In fact, let's get rid of some of that line right there. There we go. Let's simplify the top. In fact, let's just go over here in a different color and do 1 plus h squared. 1 plus h squared. Okay, so that's going to be 1 plus, so first, outside, inside, last. I think you should be starting to almost be able to do that in your head. That's 2h, right? 1h plus 1h is 2h, plus h squared. And now we're going to put that back. 4 minus, now remember, we're taking away all of this. So it's minus all of this. And these signs have to be paid very close attention to, all over h. So what we're going to have to do is switch all these signs here. And I'll do that first. So it's going to be 4 minus 1 minus 2h minus h squared minus 3. So I basically distribute this like little minus 1. In fact, I'm going to delete this, but I'll show you. There's like a little minus 1 that I filtered that through to get this. Okay? I guess I can leave that there. Doesn't matter. All over h. Okay, now let's clean the top up. So I have, this is 3. 4 minus 1 is 3. So that's 3. And then this is minus 3. So basically these numbers are going to go away. Okay, so all of these numbers here are going to go away. And I'm going to be left with the following. Negative 2h minus h squared over h. Okay, which each of these terms have an h in it, so I can simplify, because basically this works into this. Right? I mean, that's what that simplifies into. And then the h's cancel. Sorry, it's getting a little bit small there. That's what this would be. This right here would be -2, and this would be minus 1h. Okay, and as we take our limit as h approaches 0, that means when we're all done with that, we stick 0 in for h. So that's going to be -2 minus 0, which is -2. We'll put a big old victory lap circle around that because this is the slope of the tangent line. So that, which is good, right? Because this green line appears to be definitely negative. I don't know if it's -2 or not. According to the math, it is. But we'll, find the equation of a tangent line and plug it in there. In fact, you could do it on your calculator and really see it well. But that's the first step. So the first step of this answer here is -2. Now, let me get some real estate, and we'll do the next part. Find the equation of the tangent line. Well, if you remember, our point when we evaluated it was at 1, 3. And the slope that we just found was at -2. Right? Everybody remember. Let's go back. Let's look at it one last time. This is the point 1, 3 I was talking about. Okay? That's that point. What we have to do now is use the point slope formula, which I'll write up here. It's y minus y1 equals m times x minus x1. And if we plug it all in there, where this here would be x1, y1, we can get this to work out quite easily. This is going to be y minus 3 equals -2 times x minus 1. Okay? We'll distribute. So y minus 3 equals -2x plus 2. And add the 3, so y equals -2x, and that would be what? Plus 5. And that would be the equation of a tangent line to that. Now, let's go ahead and put that answer here. That would be y equals -2x plus 5. And this one was -2. So there are our answers so far. The equation of the normal line. Remember, normal means perpendicular. Well, if our slope is -2, a parallel slope to that is a negative reciprocal. So if we flip this fraction over and change its sign, then this is the new slope I want to use for a normal line. It's just like finding a perpendicular line. We're still going to have it pass through 0.13. So now we do this again. So it's going to be y minus 3 equals, and this time 1/2 times x minus 1. We'll have to distribute, and we'll just grind this math out. 1/2 x minus 1/2. We'll add 3 to both sides, and I think you can see that that is what 2.5 there. So plus 2 and 1/2, or 5 halves, or 2.5, or however you want. But this is the normal line to this indicated point right here. So that answer would go right up there. And that's basically it. And now I don't have time to do it, but what you should probably do is graph the original and then the second thing, this one. So graph the original, graph this, and graph that on the same screen of your calculator and see what you got. I'll talk to you later.